Welcome back to part 3 of Stoichiometry Review Guide. We're looking at pages 5 through 7 today. Multiple step molar conversions. Again, calculator, periodic table, have all those pieces ready to go. So the key to multiple step molar conversions is that we must always convert to the mole first. So whether you're starting with mass in grams or numbers of atoms or molecules or liters, first thing to convert to always is going to be the mole. So let's practice. Here are a couple examples that are done for you. Looking at liters of carbon monoxide, step 1, we're going to convert to a mole. Once we have moles of carbon dioxide, you can go to grams. And so those 8.8 liters of carbon monoxide at STP will be equal to 11 grams of carbon monoxide. Here's another example. We're starting with grams, and we want to figure out how many atoms that's equal to. First step, always convert to mole first. Grams on top, grams on bottom. Now I have mole on top. I want to get rid of that. I'm going to take that mole on top, cancel it out with a mole on the bottom. We know how many atoms are in a mole, and so we get that answer. Good. Let's do some together. So this question is asking us how many oxygen molecules are there in 3.36 liters of oxygen gas, of course at STP. So we're going to always start with the given. Our wanted is molecules. There is no conversion factor to go from liters to molecules, and so we have to go first to moles. So we're going to do 3.36 liters of oxygen gas. I want liters to go away, so I'm going to put it on the bottom. We always convert to the mole first. How many liters in a mole at STP? There are always 22.4 liters in 1 mole at STP. We have canceled out liters. We have moles, but we don't want to keep moles. We want to go all the way to molecules. So I'm going to add another chunk of railroad track. Right now, moles is on the top. I want it to go away. I'm going to put mole on the bottom. I want to turn my moles into molecules. And what do we know about moles and molecules? We know that in 1 mole, there are 6.02 times 10 to the 23rd molecules. Now our moles are canceling out top and bottom. We're left with the label molecules, which is good because that's what we want. Now we're going to do our math. 3.36. You have a couple options. 3.36 times 1 times 6.02 times 10 to the 23rd divided by 22.4 times 1. Or we can do 3.36 divided by 22.4 times 6.02 times 10 to the 23rd. Either way, you'll get the right answer. When we do that on the calculator, let me turn it back on. We are going to get 3.36 times 1 divided by 22.4. You can go ahead and click enter here if you want to. You don't have to, but you can. This is our number of moles. I'm going to multiply that answer by 6.02 times 10 to the 23rd. Again, I much prefer the second function EE button when working in scientific notation. And our answer is 9.03 times 10 to the 22. That's exactly the number of sig figs that we need. So final answer, 9.03 times 10 to the 22 molecules of oxygen gas. Next one, find the mass in grams of 2 times 10 to the 23rd molecules of fluorine. So we're going to always start with our given. We're going to get to our wanted, but again, I can't go straight to mass. First, I have to go from molecules to moles, and then from moles to mass. So I have 2 times 10 to the 23rd molecules. And I'm going to get rid of molecules by putting it on the bottom. Turn my molecules into moles. I'm going to put mole on the top. We know that in 1 mole, there are always going to be 6.02 times 10 to the 23rd molecules, regardless of what the compound is. Molecules top and bottom cancel out. We're left with moles, but I don't want moles. I want to go all the way to mass. So now I'm going to put mole on the bottom. I'm going to turn my mole into grams. How many grams in 1 mole of fluorine gas? We need to look at our handy dandy periodic table. So here we are, fluorine is 18.998, but I have F2, so I'm going to take that 18.998 and multiply it by 2. That will be the mass of fluorine. So we get 37.996 grams per mole. We can do 2 times 10 to the 23rd times 1 times 37.996 divided by 6.02 times 10 to the 23rd divided by 1. Or we can do piece by piece by piece. We'll get the same answer regardless. So if we do 2.00 times 10 to the 23rd times 1 times 37.996. That is our numerator divided by, we can use parentheses, 6.02 times 10 to the 23rd times 1, if you really want to be technical, but you could absolutely skip that. We're going to get 12.6 with lots and lots of digits. Since I'm going to keep only 1, 2, 3 sig figs, I'm going to keep 1, 2, 6. That 2 is going to leave that 6 a 6. So final answer is 12.6. The label is grams of F2. Good? Good. Let's do some more. Let's figure out the volume in liters of 14 grams of nitrogen gas at STP. So nitrogen gas, remember, is part of Brinkelhoff. And so nitrogen gas is going to be diatomic. It is N2. So we'll take that 14.007 on the periodic table times 2. Our mass will be 28.014 grams per mole. So we're going to start with our given, that 14 grams of nitrogen gas. 1 mole of nitrogen gas has a mass, because I'm starting with grams and I want it to go away. Putting grams on the bottom, we figured out that that mass was 28.014 grams in 1 mole. Grams on top and grams on bottom cancel out. I have moles, but I don't want moles. I want to go all the way to volume. So to get rid of this mole on top, I'm going to put mole on the bottom. I want volume in liters on the top. Moles on top and moles on bottom cancel out. How many liters in 1 mole? We know that that is 22.4 liters in 1 mole of gas at STP. So now I can do 14 times 1 times 22.4 divided by 28.041. Sorry, 014. Or I can do 14 divided by 28.014 times 22.4. Either way, we should get, after sig figs, 11 liters of nitrogen gas. Next one, 6.2 liters of gas exhaled. 78% of that gas was nitrogen. How many molecules of nitrogen gas was exhaled? Well, so first we're going to have to figure out how many liters of just nitrogen gas we have. So 78% of 6.2 liters is nitrogen. Remember that in math, a percent turns into a decimal by dividing by 100. So 78% divided by 100 gives us 0.78. So 0.78 or 78% of in math land is multiplication. So 0.78 times of 6.2 is going to give us 4.836 liters. I didn't check sig figs yet. Ideally, we never check sig figs until the very end of our until the very end of the problem. So I'm going to leave all those digits for now. This is going to be my given. If I have 4.836 liters of nitrogen gas, and I want to turn that into molecules of nitrogen gas, first of all, we have to get rid of liters and turn it into moles. Always, always moles first. We know that there are 22.4 liters in 1 mole of any gas at STP. Liters is canceled out. I have moles, but I don't want to keep moles. I want to turn it into molecules. So I'm going to put mole on the bottom, and I'm going to turn my moles into molecules. We know that there are 6.02 times 10 to the 23rd molecules in 1 mole of anything. So now I can do my math. 4.836 times 1 times 6.02 times 10 to the 23rd divided by 22.4. And we should end up with 1.3 times 10 to the 23rd molecules of nitrogen gas. I'm going to keep those 1, 2 sig figs because I have 1, 2 sig figs in my original problem. Good. One more chunk of practice for multi-step conversions. When I mean one more, I mean 5 parts of one more. So aspartame is an artificial sweetener, marketed as NutraSweet. This is the very large molecular formula for aspartame. So first part of the question is asking us to find the gram formula mass. That's molar mass of aspartame. So we're going to take our 14 carbons, our 18 hydrogens, 2 nitrogens, 5 oxygens, and add them all up. So we'll do 14 times 12.011, 18 times 1.008, 2 times 14.007, and 5 times 15.999. We add all those up. You don't need to watch me push buttons on that calculator. Let's just go with the final answer. Should be that. Grams per mole. Good? So how many molecules are in 10 grams? Well, let's start with our given. Figure out a way to get to our wanted. So our given is 10 grams of aspartame. Step 1 always is to turn our mass into moles. And I'm going to use the molar mass that we found here in part A. So we know that there are 294.307 grams per mole. I'm going to put that gram number on the bottom because I have grams on the top and I want it to cancel out and put 1 mole on the top. I want to turn that into molecules. Grams is canceled out. I have moles. Get rid of moles by putting it on the bottom. Put molecules on the top. Moles on top and bottom cancel out. In 1 mole, there are always going to be 6.02 times 10 to the 23rd molecules. 10 divided by 294.307 grams times 6.02 times 10 to the 23rd is going to give us, with only 1 sig fig given to us, 2 times 10 to the 22 molecules of aspartame. So now we are trying to figure out how many grams would be equal to 1.56 moles. This is actually easier than the last question because there's only 1 step. We just need to go from moles to mass. So if I'm given 1.56 moles, I want to get rid of moles. I'm going to put mole on the bottom. How many grams, because I'm looking for mass, how many grams in 1 mole? Well, we're going back to this answer for part A. There are 294.307 grams in 1 mole. It's 1.56 times 294.307 divided by 1, if you want to be super particular, is 459 grams of aspartame. This next chunk is asking how many molecules in 5 milligrams of aspartame. Here's a tricky thing. Milligrams is not what our periodic table tells us. The periodic table tells us how many grams, not how many milligrams. So step 1, we're going to turn our 5 milligrams into grams. Get rid of milligrams, put it on the bottom, put grams on the top. What do I know about grams and milligrams? I know that there are 1,000 milligrams in 1 gram. Milligrams is canceled out. I now have grams. I want to get rid of my grams and turn it into molecules, but I can't do that. I have to go to moles first. So I have grams on the top. I want it to go away. I'm going to put grams on the bottom. Turn those grams into moles. How many grams in 1 mole of aspartame? Back to that answer to part A, 294.307. 294.307 grams per mole. Grams has canceled out. I have moles, but I don't want moles. I want molecules. So 1 more chunk of railroad track here. I have moles on top. I want it to go away. I'm going to put it on the bottom. I want to turn my moles into molecules. How many molecules in 1 mole of anything? Well, there are 6.02 times 10 to the 23rd molecules in 1 mole. So I do this math. 5 times 1 times 1 times 6.02 times 10 to the 23rd divided by 1,000 divided by 294.307. Make sure to put your division into parentheses. if you do 5 times 1 times 1 times 6.02 times 10 to the 23rd divided by 1,000 times 294.307, that would need to be in parentheses. Your other option would be 5 times 1 times 1 times 6.02 times 10 to the 23rd divided by 1,000, and then push once more the divided by button, divided by 294.307. Regardless of which way you do that, and you check your 1 sig fig, you should get 1 times 10 to the 19th molecules of aspartame. Last but not least, how many atoms of nitrogen in 1.2 grams of aspartame? So this one's kind of tricky because I don't want molecules of aspartame, but now we're going to atoms of just one of those elements in aspartame. I still need to go to moles first, so I'm going to do 1.2 grams of aspartame, turn it into moles. They're 294.307 grams in 1 mole. I put grams on the bottom because I want it to go away. I have moles. I'm going to turn moles into molecules first. I know that there are 6.02 times 10 to the 23rd molecules of aspartame in 1 mole of aspartame. So now I have how many molecules of aspartame there are. And I go look here, and I see that in every 1 molecule, there are 2 atoms of nitrogen. 2 nitrogens in every 1 aspartame. So in every 1 molecule of aspartame, there are 2 atoms of nitrogen. So we got our grams to cancel out, our moles cancel out, molecules cancel out, and now I'm left with atoms of nitrogen. Do all that math, and you should get 4.9 times 10 to the 21st atoms of nitrogen. And that's all we've got for this chunk of the review guide. Next up is percent composition.